Today we continue our Bernoulli probabilities with the probabilities of at least and at most problems. Let's go to page 1-2. When we're anticipating success or failure in future events, we're often interested in the success of at least or at most. Let me give you an example to help you understand. If I have 5 $10 bills in my pocket and I tell you I'm going to give you at least 2 of them, at least means that many or more. So you could end up with 2 or 3 or 4 or 5 $10 bills. If I have those same $10 bills in my pocket and now I tell you I'm going to give you at most 2 of them, at most means that many or fewer, including 0. Don't hurt 0's feelings. So you could end up with 0 or 1 or 2 of those $10 bills. So we'll take the idea of at least and at most and apply it to yesterday's exactly problems on the rest of the document. So I have probability of getting at least 8 heads when a coin is tossed 10 times. At least is that many or more. So when I set this up, the first thing I do is write that down to help myself. At least 8 out of 10 is 8 or 9 or 10. At least is that many, 8 or more, all the way up to that 10. Now I'm tossing a coin and I'm looking for it to land heads up. So the probability of success is the probability of it landing heads up, which is 1/2, which means the probability of failure is the probability of it landing tails up, which is also 1/2. Again, this is the work you show to receive credit. You show your probabilities of success and failure, you show your or statements, and from this point, each of those individual parts is yesterday's lesson. So I find the probability of exactly 8, exactly 9, exactly 10, or means add. I add them together at the end. So let's find the probability of exactly 8 out of 10. So that's 10C8 times the probability of success, 1/2. I want 8 successes, so I raise it to the 8th, times the probability of failure, 1/2. Squared, because if I'm successful 8 out of 10 times, I fail 2 out of 10 times. Or means add. So I add to that the probability of exactly 9 out of 10. 10C9 times probability of success to the 9th times probability of failure to the 1st, because again, if I'm successful 9 out of 10 times, I fail 1 out of 10. Or means add. And I add to that exactly 10 successes out of 10. 10C10 times 1/2 to the 10th, probability of success to the 10th, times probability of failure, 1/2 to the 0. I succeed all 10 times, I don't fail. That is your minimal work. From here, you go to your calculator and just type in that great big string of numbers. Be careful with parentheses and PEMDAS. But otherwise, if you're careful, this is really a calculator problem after the setup. You can do each individual part if you choose. Some people will choose to do that, but what you'll see me model in the videos and in class is just typing the one big long string of combinations and multiplication. So follow my work. You should be doing the same thing in your Inspire so that you know how to do it when you have to do it on your own, and then check your answer against mine. Okay, so finally after typing that all in, you get 7 out of 128. So the probability of getting at least 8 heads in 10 coin tosses is 7 out of 128. There is full work, full credit. Try a couple more. Assume that in the United States, 1/5 of all cars are red. Suppose you're driving down the highway and you pass 6 cars. What's the probability that at most one of the cars you pass is red? At most means that many or fewer, including 0. So we're going to say at most 1 is 0 or 1. I've already written down my probability of success, which is getting a red car, 1/5. And my probability of not getting a red car or probability of failure is 4/5. So again, at most one red car is 0 or 1. And once again, these become individual exactly problems that you add at the end. Please feel free, if you understand the pattern, to fast forward, check your answers against mine. If you get it, that's fantastic. And you have a much shorter video to watch. There's your minimum work for full credit. Now go to your Inspire and type in the string of numbers. Again, I'm not going to talk you through it. You can watch, you can try on your own, you can pause, you can fast forward. Do what you need to do to learn how to solve this kind of a problem. Here we have 2048 over 3125 is our final probability. So the probability that at most one car is red out of 6 that I pass is 2048 over 3125. So for number 3, I have the same situation, the same red cars, the same probability of success and failure, but here we want to find the probability that at least 4 of those red cars or at least 4 of the 6 cars you pass are red. So for this last problem, I'm going to show you the setup again. I don't show you every single calculator button push because I think it's terribly boring. Make sure you can set it up. At least 4 out of 6 means 4 or 5 or 6. And again, each of those is an individual problem. If it were me, I would be pausing the video and trying to set these up on my own and then checking your answers against mine. Again, I do not show every calculator button push at the end. I show you the beginnings. I remind you that you can copy and paste since you already have your probability of success and failure from question 2. You can copy paste your string of combinations and probabilities and it'll save you a little bit of time. You don't have to do it that way if you're worried about mistakes. Do what you do best using your Inspire. And the rest of this is up to you to check and see how you did. Again, here I'm just showing you how to edit. I went up and copied and pasted that first string, and I'm just changing it accordingly to my new problem. And finally, once I'm done typing, I get 53 out of 3,125. So the probability that I see at least 4 red cars out of 6 is 53 out of 3125.